Types of data. Qualitative data or non-numerical data. From the large data set, we have the daily mean wind speed on the Beaufort scale, and we're using descriptive terms. Non-numerical data. Shirt sizes. How much pain is a patient feeling? The subject studied by a student. A rating of effort on homework. Quantitative data is numerical in nature. We have two types: discrete, things that you typically count, and continuous, things that you typically measure. An example of quantitative discrete data: the favorite instrument for a number of people. And this data recorded in a bar graph. An example of quantitative continuous data: we have the height of some oak trees. We have grouped data with frequencies. A histogram of this data: frequency versus height. An example of quantitative discrete data: we have a small data set. For a large data set, we can use a frequency table. Discrete data can also be grouped. So in this example, we have the number of students in a classroom. Here we have a classroom that has anywhere starting from 10 students and up to and including 19 students. There were 18 such classrooms in a school. The data is grouped. It is discrete because we're counting the number of students in a class. And because the data is grouped, we calculate estimates. We don't have the original raw data for the number of students in each class. Quantitative continuous data: a small data set. Large amounts of continuous data is best placed into a grouped frequency table. Any calculations you do using group data lead to estimates. The data recorded here is rounded, so a value of 19.2 would be in this class. A value of 19.7 would fall into this class. The width of this class is not 29 minus 20. It is not 9. The width is based on the class boundaries, and the class boundaries here are 19.5 to 29.5, and that gives a class width of 10. The midpoint of this class is 24.5. The data here is not rounded, and the class width is based on the class boundaries again, and the class boundaries here are exactly what we see. So for instance, in this interval, the class boundaries are 20 and the 30, so the width is 10 and the midpoint is 25. Primary and secondary data. Primary data is data that you've collected yourself, and secondary data has been sourced from elsewhere. So we need to look at time and cost. It's more costly to collect data yourself, and it takes longer. So time and cost is an advantage for secondary data. How old is the data? Well, if you're collecting primary data, you're collecting it yourself, and it's current data. It could even be real time data. Secondary data has been collected in the past. The sampling method used for primary data, that's in your control. For secondary data, you don't have any control over the sampling method that was used. So that could lead to bias, because you control the sampling method yourself. For primary data, you can collect data without bias, but for secondary data there may be bias in the way somebody was collecting the data. You can collect exactly what type of data you're looking for primary, but for secondary you don't have any control over that process. A census versus a sample. So we have a population. If we analyze all of the data in the population, what we're doing is a census. It's accurate, but it's very time consuming and costly. If you work out things like the mean and standard deviation, they're called population parameters. If you take a subset of your population, So you might be using one of these sampling methods. Your data is not as accurate as the census, but it's a quicker process and it's cheaper. And here you've worked out your mean and standard deviation. What you've calculated are sample statistics.